Characteristics of even degree polynomial. So the question here is, describe the characteristic of a degree 6 polynomial with positive leading coefficient. So what I have here is two examples of degree 6 polynomial, and they will help us to describe the characteristics of these polynomials, right? So most of the characteristics which I am talking about are applicable for any even degree polynomial, and some answers which I am going to give will be specific for degree 6 polynomial, right? So one of the most important characteristics when you look at the figure is, let me make some red bullets here to list out the characteristics. So most important things which you notice is that the graph is from quadrant 2 to quadrant 1. Whenever we see a graph, we see it from left to right. So it moves from quadrant 2 to quadrant 1, right? So that is the first thing which you see, that it moves from quadrant 2 to quadrant 1. Now since it moves from quadrant 2 to quadrant 1, then it need not cross the x-axis, correct? It could go straight from here to there, right? So that is to say that it may not have x-intercept. So that is very typical of even degree polynomials. So they may not have any real zero. When we say they may not have x-intercept, that means a couple of things. That means no real zeros, right? That means all the roots are imaginary, things like that. So they may not have x-intercept. Now the other things which you see from here is that there is the end behavior. Let's talk about the end behavior now. The end behavior is kind of very typical. End behavior here is, as x approaches minus infinity, so as you move this side, y approaches plus infinity, right? And as x approaches plus infinity, y approaches plus infinity. So basically what you see is that a degree 6 polynomial will always approach positive infinity, right? So both sides are up. When you see it, you will see both sides up, correct? So that is the kind of behavior, both are on the same sides. So end behavior is you see both on the same sides, so correct? So if you see a graph where both sides are up, right? So both ends are pointing up, right? Are up in this case, correct? Now, so then how many turning points can this have? Let's look into those turning points. Now since the graph has to go from quadrant 2 to quadrant 1, the turning point has to be 1, right? At least. So as far as turning points are concerned, number of turning points will be at least 1. And now think about it. If it turns once, let's say it turns once, then it can go. But if it turns a second time, it is going towards the quadrant 4. It has to turn another time to come back to quadrant 1. So therefore, the turning point could be 1, and the next is it cannot have 2 turning points. Then it will have 3. Because if it turns the second time, it has to turn back so that it can go to quadrant 1, correct? So it can have 1, 3, or 5 number of turning points if it is degree 6. In general, if it is degree, now let me put a number here as n, which is n is even, then the number of turning points will be odd numbers like 1, 3, 5 till n minus 1, correct? So that is in general turning points. Now let's talk about zeros. So when we say zeros for the function, that means x-intercepts, right? So we say zeros or x-intercepts, right? Let me call x-intercepts to be precise. Now as you can see, we could go from quadrant 2 to 1 without even touching the x-intercept. So the minimum is 0 for even degree polynomial. And it could go once, that means like as shown in this, x to the power of 4. Or it could go, if I pull it down a bit, then there could be 2, right? Do you see that? So that way there are so many combinations. So it could have 1, it could have 2, it could have 3, and maximum is the degree. So up to the degree, which is 6 in this case, but in general this will be n. So it will be 0 to n is the number of zeros for an even degree function, correct? So think about it. This is a graph which is having 3 zeros. If I pull it down, then the x-intercept can cut it here with 6 zeros. Do you see that? So it could have so many zeros with it. Now let's talk about domain and range. Now domain for this function is always all real numbers. For that matter, domain of all polynomials is x belongs to real numbers, right? So that is for all the polynomials. As far as range is concerned, in general, we say that y belongs to real numbers, but even degree functions will have absolute minimum or maximum. If it is a positive leading coefficient, then there will be an absolute minimum, right? Because it has to go upwards. It will have local maximum minimum, but absolute minimum. So it could be y greater than equal to a fixed value, right? So let me call this as, let's say, a value which is absolute minimum. Absolute minimum. So it is possible to find absolute minimum for an even degree function, right? Now, so that is not there in case of odd degree polynomials. Odd degree polynomials will go from minus infinity to plus infinity. So they will not have absolute minimum value if their leading coefficient is positive, right? So these are some of the characteristics which we can list out, and then we can say there is one even symmetry. So a even degree polynomial may have, not always, may have even symmetry. So even symmetry is that they are symmetric about y-axis. And mathematically, you try to find f of minus x, and if you get same as f of x, then we say that the function is even, right? So that is possible. And I have given one specific graph, which is degree 6, and it has even symmetry, right? So there is a possibility. So every polynomial will not be of degree 6 will be even, right? It is even degree, but not even symmetry. So the way to recognize it like this, kind of like this, if I give you an equation like x to the power of 6 plus 2x to the power of 4 plus x squared plus 3, for example. Now here all these exponents are even, right? This is also even exponent. It could be treated as x to the power of 0. So this function will be even function, right? But if I introduce x to the power of 3 in between, it becomes neither. So that is kind of important to understand. Now this function drawn here is also even. We have x squared, and this is x minus x plus 3 whole square, and this root is at x minus 3 whole square, right? So it makes this function even. So there is a possibility of even symmetry in even degree polynomial, right? So these are the major characteristics which we have covered. And lastly, let's give it a general equation. That is, we can write function with even degree as like this, or you can also write this as in terms of its roots. For example, x minus x1 times x minus x2 times x minus x3 times x minus x4 times x minus x5 times x minus x6, where maximum number of roots can be 6. That means the zeros, right? Now roots could be double, triple, like that. So degree of the roots could be more than 1 also. So that will decide about the turning points, correct? So these are, in short, the characteristics of even degree polynomial. When you look at a function, and if you see both sides facing up or down, then you know it is even degree polynomial. If they are facing up, then positive leading coefficient. If they are facing down, then negative leading coefficient. So these are the characteristics from which we can recognize an even degree polynomial. Thank you.